Okay, in this next chapter here, we're going to be discussing right triangles and trigonometry. And so in this first section here, we're talking about similarity in right triangles. Okay, and we're going to learn lots of new stuff about right triangles and their altitudes and different things like that. Okay, but let us first take a look at some prerequisite skills here and make sure that we're ready to go. Okay, so this first one asks us to write a similarity statement comparing the two triangles. So we see two triangles here. We see one that's maybe we could call, I don't know, ECD, and the other one maybe ADB. Okay, or maybe we don't know yet. Okay, we do see it's pretty important here, and I'll outline these maybe one more time, that angle C and angle B appear to be congruent, and we know that this one right here is actually a right angle. Okay, well, because we know that this is a line, okay, and this is a linear pair, okay, we know that basically angles EDC and EDB need to be supplementary, okay, meaning they need to add up to 180 degrees. So that means that this actually has to be a right angle, okay? So that one's also 90 degrees, which would then make these two angles actually congruent, angle E and angle A, okay? So, you know, we could write this statement in, you know, probably a lot of ways, but maybe let's just call this triangle ADB is similar to triangle, and again, we started with the two arc marks, went to the right angle, and then to the one. So EDC would be the proper way to write this, okay? Again, I think simple enough here. Okay, let's go ahead and take a look at 2 and 3. We're asked to simplify these radicals. Okay, and so in problem number 2 here, it says radical 72. And now remember, we're looking for perfect square factors of this number 72. Okay, we're trying to find the largest perfect square factor possible here. And so I might write this now instead. I know that 36 times 2 is actually 72. And I know that 36 is that perfect square number. So I can actually simplify this to 6 radical 2. And that is now my final answer. Okay, looking over at radical 27. Again, I'm looking for perfect square factors of this number 27. I know that 9 is a factor, so 9 times 3 is 27, so I can just write it like this, radical 9, radical 3. Noticing again that I put the perfect square on the left, and now I can simplify this to 3 radical 3 for my final answer. Okay, in problems 4 and 5, we're asked to solve each equation. It looks like we just have a proportion set up for number 4, so we can just use the cross products property here, where we take the product of the means, so this would be 5 times x, and we set that equal to the product of the extremes, which is going to be 3 times 8, which is 24. And now we can just solve this pretty simply by dividing each side by 5. And we get that the value of x is going to be, sorry about that, got a little ahead of myself. It's going to be 24 over 5. Okay, and that would be our final answer here. Okay, on this last one, on number 5, remember, we're trying to find our answer for x, so the first thing we need to do is isolate x squared. And so what I'm going to do here is divide by 2 on both sides to get now that x squared equals 25. And then, again, since our variable is being squared, I will do the opposite. I'll take the square root of both sides, remembering that I have to take into account my positives and my negatives here. So my answer is actually going to be x equals plus or minus 5. Okay, so again, I hope these prerequisite reviews are helpful for you. Again, if we have these skills going into this lesson, we'll be very successful.